All right, we're going to work with kind of a weird function right now, but it's going to show us that when we say the average value of a function, it agrees with our general idea of what an average is. Right? Usually when you find an average of things, A, B, C, you add them up and you divide by the size of the set. So you had 3 things here, so you divide by 3. And here, we're just going to do this continuously. Well, actually, for this function, it can be solved discretely, but the average value function, so this definition right here, can be used to find the averages of continuous, smooth, curved functions. But let's work on this one. So this function returns the value of I over the interval I minus 1 to I for I in, and if you remember that Z right there, that script Z is the integers. So we're looking at -3, -2, -1, 0, 1, 2, right? Not all real numbers, just the integers. So let's do this. We're only concerned with the interval 0 to 4. So let's see. For I in the integers, well, I could be 1. So I'm looking at this right here. Where does x live? So if I is equal to 1, then you get 1 minus 1 is less than x is less than 1, which gives 0 is less than x is less than 1. Oh, okay, well, that's not that complicated. So over the interval 0 to 1, I'm supposed to return my I value, and I here was 1. So over this interval 0 to 1, I'm just going to be a constant 1. But I've got open circles, right? Because look at your definition. They're all open. Okay. What about what's going on between 1 and 2, right? So we started with I is equal to 1. Let's start with I is equal to 2 now. So if I look at this, and now I is equal to 2, 2 minus 1 is less than x is less than 2. So that's, oh, x is between 1 and 2. Okay. So when x is between 1 and 2, I'm supposed to return my I value, which in this case was 2. All right, so you see that we're kind of just getting a stair-stepping function. And how far do I need to go? Over the interval 0 to 4. Okay, so we've been through I is 1, I was 2. Now what happens when I is equal to 3? 3 minus 1 is less than x is less than 3. So between 2 and 3, your I value is 3. And we've got one more. You can probably guess that it's going to return 4. But let's double check. Between 3 and 4, so when I is equal to 4, 4 minus 1 is less than x is less than 4. So between 3 and 4, you're a 4. All right, that's the graph of the function, at least over the interval that we care about. So find the integral from 0 to 4 of f of x by using rectangles, right? We don't actually need to take a limit here or to find an antiderivative because these are, I think I can find the exact area by just using rectangles. These are constant functions. So the integral would be the sum of these rectangles, or the areas of these rectangles. They all have a base of 1, so their areas are equal to their heights. It has an area of 1, this has an area of 2, 3, and 4. So if I add 1, 2, 3, and 4, I get, what is that? 4 and 3 give me 7, 9, 10. So the area between 0 and 4 underneath this function, which we were able to find by just using 4 rectangles, is equal to 10. All right. Now give the average value. So this definition up here, or yeah, that's the definition. Might be a theorem, but the average value, so let's denote that by f bar over the interval 0 to 4 is given by the integral from 0 to 4 underneath the function divided by b minus a, which in this case is 4, right? 4 minus 0. Oh, and we already know the integral between 0 and 4, right? That was this part. Returns 10. So the average value of this function over this interval is 10/4. So that's using calculus, but we can also find this by just doing what we know since grade school. How do you find the average of a 1, a 2, a 3, and a 4? 1, 2, 3, 4. And then how many of those numbers are there? There's 4. So you get the same thing. But now, using the idea of an integral, you can take average values of more complicated functions than just constants. You can have smooth curves and find the average of all of these y values.